Let me just get this the way. Suppose we have two hypotheses, right? That's called the null hypothesis. And that's called the alternative hypothesis. Usually the alternative hypothesis is the research hypothesis. I'm assuming that that one is, okay, I believe that the mean is equal to a value, K, constant value that I think is true. Always the null hypothesis is what I would think is true, or what I was assuming is true. And then I can say, well, no, it's not. The alternative is not true. The alternative is, well, maybe it's not true. It's not equal to this value. Okay, in that case, what we have is, okay, we say it's equal. So when we say it's equal or not equal, because the hypothesis, null hypothesis equal to, and the alternative is not equal, what we try is testing that given normal distribution, the mean could be, and the representing that value is between these 2 points. Say between these 2 points. For any reason, the statistic that we use to do the test is falling in this area, so that one is the rejection region. Okay. You know that one is 1 minus alpha, so that one is alpha half, and that one also alpha half. In that particular case, because it's two-tailed hypothesis testing two tails. Okay, you have two tails. So what we're testing here is, okay, given this condition that we set up, 90%, 95%, 99%, whatever that we set up here, we test if that is true or not, could be true or not, statistically speaking, I say, right? This is what I was just trying to tell there. But that one could be that way, could be just one direction. When you don't have any direction, you don't know what direction to take, so you get this, you have to use no equal to. But so you have a direction like this, then you think it's greater than, right? That area is the alternative section, okay? And that area is the null section. So if we think is the null hypothesis is equal to K, but the alternative hypothesis is greater than this value, okay? So we know a direction, then we work this that way. That's the case. So we need to have a test and test that one. Suppose it's Z or it's T or whatever, in those cases, you define the rejection region. What is the rejection region? If the value Z is greater than this value, then you reject the null hypothesis. Okay, you reject the null hypothesis, you are accepting the alternative hypothesis, actually. So what is going to be true is greater. You don't know which is the value, but it's not equal to K. It's greater than K. We don't tell what is the value, but we know it's not already K. Whatever the K is could be the value. And also we do this direction, right? That one. When there's less than, so the hypothesis is going to be mu is equal K, but the alternative is mu is less than K. Right? This is the three cases only that we have. That happened for mu, that happened for proportion, And that also happened for standard deviation and for anything, standard deviation and variance. That's what we're talking about there. So that is the theory. We know how to get this value because we set out the value. So we're talking about testing at 90%. That means that area is 90%, that is 5%. Is that area is 90%, that area alpha half, because we have to tell that is 90, so that's 5 and 5. Remember, always the total area should be equal to 1. Should be equal to 1. Okay, so this is the base we come back to and repeat this in a minute. Okay, let's go to here and let me share over here. And we go. Now let's read this question. Okay, the brokerage firms needs information concerning the standard deviation of the account balance of the customers. Okay, the standard deviation. From previous information, it was assumed that to be 250. Okay, so let's write down is the one here. Is assume 250. What is that? Standard deviation. In a random sample, 61 and 61, account was checked. The standard deviation was 200. I'm using S 286.20. And alpha, given alpha, 0.01. Given, the alpha is given, 0.01. Test the first assumption. Assume that the account balance are normal distributed. Okay, fine. That's good. Has to be a condition. So, is any duration here? The standard deviation of the account balance and its customer. For previous information, it will assume this value. A random sample of 61. Need to test what? Test the assumption. That is 250. Okay, and they don't tell you is greater than, or they say this equal to 150. That's what I'm telling me here, right? So because of that, I'm setting the first case and have the information. So the null hypothesis is just 250, or in that case, the standard deviation, right? Let me just put it in the right way. The parameter is standard deviation. It's 250, and the alternative hypothesis is not equal to 250. That's it. So that's important. What is important is the alternative, because always the null hypothesis is the equal one. Okay, always. Well, what is important is the alternative in this case. So let's go to our studies, right? And we have all the information right here. And what do we need to do? You need to go to analysis, and we're looking for hypothesis testing. And we're talking about what? Standard deviation. You go to standard deviation, one sample. Check out what do we need? We need to know alpha. Significance is alpha, 0.01. 0.01, the standard deviation that is claimed is 250. Okay, that's just the one, the null hypothesis. The sample size was 61. And he got a sample standard deviation of what? Checking, what are we doing is identifying all the different variables and parameters that we need to enter. It's 286.20. And then we do the evaluation. And we have all this information, interesting information so far. Okay, this is very, I don't know, you don't see this one, right? Let me just check this. Where is my, here we go. Here is the information, right? So what is that telling me? Okay, even you got a plot. Let me also, before going to the plot. So you check this information. What does that tell you is the test statistic that we're using according to the sample information. You see a chi-square. Using a chi-square 78.6. And we compute the two values, the lower than the upper chi-square is those two values. Okay. Understand? Because we got two values because we got no direction, right, at all. Okay, and that one is, let me check this the way, right? So I have one here, 35.5. I have one here, 91.90, and that is the given by the 1%. Okay, that is given by the 1% because we're talking about alpha is 1%. That is in that case alpha half. So that is 1% divided by 2, or 0.50%, or 0.005. Actually, this is what it is. Okay, that's given here, the significant level. So those is doing by the software. So now that is the area. So what is the rejection region? Any value that is greater than, that's a rejection region. You need to reject in this two region. But now when you check the test is 78. 78 is before this one, after this one. 78 is right here, you know, in that area here. 78.6. What does that tell me? Well, we cannot reject the null hypothesis. We take it like, oof. Oh, what is it? What I did? Oh my God. Oh, we got again. Sorry, guys. My goodness. Okay. Pushing my fingers in some other place. I was telling that one is the statistic. And then we compare this one again, those two. If that one is, you know, in that area, on that area here, we should reject the null hypothesis because it's less than this one, or greater than one is in that area. So we don't reject the null hypothesis because it's just is area for the null hypothesis, actually, right? Is the area for the null hypothesis. So it's right here, the null hypothesis area. So conclusion is we don't reject the null hypothesis, and the value is 250 is okay. Is no way to reject that affirmation, that statement, that particular thing. Also, here is the information called p-value. The p-value given here is a rule. If the p-value is larger than alpha, we fail to reject the null hypothesis. That is the case, okay? That's the case. The p-value is 0.10 and alpha is 0.01. And then we fail to reject. What I mean, we fail, we don't reject the null hypothesis. And in testing, we say fail to reject. We want to reject the null hypothesis, but we cannot reject it. So we say we fail to reject the null hypothesis. Something else, and that happened for all, parameters, proportion and mean. Here, using confidence intervals, if the value of the statistics is in between this, this area, or the confidence interval contains the statistics, then we should we should be okay, and then we don't reject the null hypothesis. So in that case, you see here the standard deviation is between 231 and 371. And what is 250? 250 is in between, right? We say it's 250, and that's what it is. It's between these two values. So that is okay. That could be real. That could be true. And so all these answers, what are telling me is that could be true. All the tests, 3 different tests, giving me the same thing, that one, that should be the real standard deviation. Or we can take it like a true, statistically speaking, of course. Right? So that is the analysis you need to do, and the way you need to input this into a stat disk, right? Very good. Okay, let's see. What time is it? Oh, 7. Okay. Let's clear this. I'm moving to number 12. Number 12 is the bank claims that the mean waiting time in line is less than 4.4 minutes. I mean, claim is kind of, this is the one we want to test on the claims. Okay, and less than 4.4 minutes. This is what they think it is. So we take a sample to test it, 20 customer, and has the mean of 4.2 minutes, which with a standard deviation of 0.08 or 0.8 minutes, and if the confidence is 0.05 or 5%, test the bank's claim using p-values. Okay, but in that case, we want to use a statistic, so you don't need to worry about just to get the information right there. Let's just share, because you don't see what I'm just talking about here. I don't know why it's not shared. I'm not sharing this one. Oh, guys, give me a second. I need to Okay, I'm back. What are we at? Okay, the bank, right? So here is what I'm talking about. The claim is they think the mean waiting time is the mean is equal to 4.4, and they don't tell you, take a sample, and the sample is equal to 20, and the mean was in the sample equal to 4.2, when the standard deviation in that sample of 0.8. Okay, if alpha is given 0.05 or 5%, test the band claim using, claim. Here is less than, this is the quantifier, less than 4.4. So it's important because mu is less than 4.4. You see the alternative, how that works. And now you see how we want to set out this in our studies. By default, the first one is the standard deviation is no claim, okay? It's equal to the claim. So we have this hypothesis alternative. We can do, we can do this. We can have equal, greater than, less than. By default, always is equal to. But that's why I didn't change in the first one. But now they claim it's less than. So you need to change that one here. Okay, you have to be careful with these quantifiers. What is the direction they want to test? The significant is 5, and then you go 5.05. The standard deviation is not for let me go back again. Hypothesis testing for the mean. Actually, it should be started with this one. Mean one sample. Okay, again, that one is equal. We go to less than 0.05. That one, the mean is equal to claim mean is 4.4. The claim is 4.4, right? Population standard deviation, we don't have any. See, we have something information, we plug it in. And then the sample size is coming here. The sample size was 20. And the sample size produces or have a mean of 4.2. That's the mean, sample mean. Sample standard deviation was 4.8. So you enter the 0.8. And we have all the what we need to. What we need to do is do an evaluation and get this information, okay? You see, the system does, I mean, when you're using sample size and using information from the sample, the system use the appropriate test. Here, we're using t-statistic. I mean, just get the, show you what I'm doing. Here, we're using test statistics, the test, t-tests. And how do we read this one? Okay, like we read before for standard deviation. Here is the hypothesis that we are testing, right? Be sure that's the one. And now you have what? The test is this. The test is statistic given by the sample. The critical value is this one, just one value, right? Remember, we're working on something that is, we draw this one, is here. Okay, and here is the value of critical values minus 1.772, right? And that one is minus 1.11. Okay, that one is minus 1.11, and minus that is 0. Right? Minus is closer to 0 than 1 point this one, so that is somewhere here because it's negative. So here is 1.1 negative. So, and that is the rejection region, and that is the no rejection region, the null hypothesis. So we should not reject the null hypothesis. That's what, or we failed to reject the null hypothesis. This should be the answer. fail to reject the hypothesis. Also, the p-value. The p-value is larger than alpha, we fail to reject. If the p-value is less than alpha, we reject the null hypothesis. It's very, very easy just to do. So in that case, the p-value is 0.13, and that one is larger than what? That one is larger than this one here, 0.05. So we fail to reject. And also 4.4 is right in the middle of those two values, 3.8 and 4.5. So 4.4 is also, using a confidence interval, is also a possible statistical speaking value. So that would be true. The statistical speaking, that is, we fail to reject the null hypothesis. And that consistent in all the tests that we're doing here, confidence interval, p-values, and critical region, should be the same result. Should be the same result, right? Okay, guys. So now you have idea how to use the statistics for different situations, different hypotheses. Okay, that one is for the standard deviation again. I mean, for the variance, that is exactly the same like a standard deviation. Remember, you need to use a standard deviation in case the input is requiring you the standard deviation. Sum of population normal, that we did this for the previous one. And that one, anytime that you have raw data, you need to create a column and enter those values in that particular column and enter and get it. The one is for a local, just get this, get the information, just to, you need to read this kind of question twice. It's very, this is my recommendation. Local group claims that the police issued at least 56 parking tickets a day in their area. 56 parking tickets. To provide a point, they randomly select 2 weeks. The research yields a number of tickets used for each day. The data is this. List below. The alpha of testing, alpha is 0.01, 1%. Test the group claim. Okay. Test the group claim. Okay. That ticket is, you don't see any percentage here. What that means is at least 56 parking tickets a day. And then at least it's a direction. Okay, in that case, that particular case, we're talking about what? We're talking about the mean, right? We're talking about the mean. So that is 56 parking tickets per day. This is kind of average. Okay, it's an average. And so they took this 2 weeks, and then you take the different tickets, you take the average. So here they don't tell you is the mean, but you need to figure out that's the mean, because proportion is about percentage, and the standard deviation is about, they tell you is a standard deviation. In that case, it's just the unit is the mean. And then the standard, what we need to do is basically get the information. You refresh this. What is that information? Give it there. The screen. This one. Yeah, this one. Okay, and the given the information you see here is at least. So we say the mu is equal to 56 per day. Mu is less at least is greater than 56. At least it's greater than 56. That is alternative hypothesis. And then you enter these values in, the stat disk and use the alpha, and then you're gonna be fine just to compute the different values, and then you'll do an interpretation for these cases. Right. I want to leave this here so you can finish this one, doing a stat disk. You enter those values and this in a stat disk and use this. Well, let me see if I can do this for you guys. Just a minute. Let me get this. Okay, this is what I need to do. Okay, let's move this. Right, this is, I want to use this column just to do it. Okay, this is what we need to. Then we can have a 70. You can go anyway, 48, 41, 68, 69, 25, 70, 57, 60, 83, 32, 60, 72, 58, 14, right? 14. All right. Then we go to analysis, hypothesis testing, the mean, one sample mean, and we want to use the use data, right? I have that one in column 2. I want to do the one is 0.05, I think it is. Yeah, we're using alpha equal to alpha equal to 0.01 actually. Okay, 0.1, and then you go here, you change up 0.1, and the claim is equal to 56. And well, using that data, do the evaluation, you got it. So that is a computation. You check that one. Okay, you need to check this claim because the claim is at least, is greater than, so we need to go and put it here, do the evaluation with at least, and that changed a little bit because this is just one measure. So here, the critical value is 2.6 and the test is 1.7, is less than 1. So we failed to reject. The p-value is 0.13, is very large than 0.01. And the value of 56 is between 50 and 69. Okay, that could be true. Then we failed to reject the null hypothesis. That's the conclusion. That's it. All right. So that is the way you may work use problems. That is the exercise. Do your homework, and I want to see you the last class is going to be next Monday. We want to have a review on any comment or anything. We can just talk about this one. You have any question so far? All right, guys. I want to see you next class. Thank you for coming. Have a nice day.
Professor.